triangle PQR is right angled at P. So PQR is right angled at P. S belongs to QR. So this is QR, and this is the point S. And PS is perpendicular to QR. So PS is perpendicular to QR. If QR is equal to 2PQ, so if QR is equal to 2PQ, prove that SR, so SR is equal to 3 times QS. So 3 times QS. So using Pythagoras' theorem, and Pythagoras' theorem is c squared equals a squared plus b squared, where c is the longest side, the hypotenuse. So I'm going to take the triangle PQR. Remember, this is the right angle. So this is going to be the hypotenuse, which I'm going to call 2A. And I'm going to call this side here A, because remember, QR is twice the length of PQ. So that's why it's 2A. And this is called A. And then I'm just going to call P or Z. You can go with whatever letters you want. So the C squared is going to be the 2A. And the A squared and the B squared are going to be A squared and Z squared. So we have A squared plus Z squared equals 2A squared. So 2A squared becomes 4A squared. And we're going to bring the A squared over the equal sign, it becomes minus A squared. And 4A squared minus A squared is 3A squared. So Z is the square root of 3A. So now I'm rewriting PR as root 3A. Again, using Pythagoras' theorem, now on PSR. So PSR. So the C squared is going to be root 3A. And the A squared and the B squared are going to be x squared and 2a minus y squared. So I've just decided to call this x, but you can go with whatever letter you want. And the distance from S to R is called 2a minus y, because remember, the distance from Q to R we're calling 2a. And the distance from Q to S I'm going to call y, but again you can go with whatever letters you want. So the distance from S to R is going to be 2a minus y. So get 2a minus y. So using Pythagoras' theorem, we have root 3a squared is equal to x squared plus 2a minus y squared. So we're going to bring the 2a minus y squared over the equal sign, and it becomes minus 2a minus y squared. So we have x squared equals root 3a squared minus 2a minus y squared. Root 3a squared gives us 3a squared, and minus 2a minus y squared, when we multiply it out, and remember to multiply in the minus at the front, we end up with minus 4a squared plus 4ay minus y squared. So then simplifying, 3a squared minus 4a squared is minus a squared. Bring down the 4ay, bring down the minus y squared. So we have x squared is equal to minus a squared plus 4ay minus y squared. And this is going to be called equation 1. We're going to use this again. And then using Pythagoras' theorem on the triangle PQS. So PQS. So again, we're using Pythagoras' theorem, which is c squared equals a squared plus b squared. The c is the hypotenuse, this time it's a. And the a squared and the b squared are going to be y squared and x squared. But again, you can use whatever letters you want. So I'm going to bring the y squared over the equal sign, so it becomes minus y squared. So we have x squared equals a squared minus y squared. And this is called equation 2. And comparing 1 and 2, we notice that they are both equal to x squared. So we have x squared equals this, and then x squared equals this. So we can let each of them equal each other. So we have minus a squared plus 4ay minus y squared is equal to a squared minus y squared. We can cancel out the minus y squareds on both sides, and we have minus a squared, and we can bring that over the equal sign and it becomes plus a squared, and a squared plus a squared is 2a squared, and then we have the 4ay on the left hand side. So 4ay is equal to 2a squared, and then dividing across by 4a to get the y on its own, we get y is equal to a half a. So remember, SR is 2a minus y, so SR is 2a minus y. So we're going to swap the y for a half a. So swap the y for a half a. So 2a minus a half a is 3 over 2a. And 3 over 2a is the same thing as 3 times a half a. And remember, a half a is equal to y. So this is really 3 times y. And y is equal to qs, or sq. So instead of 3 times y, we get 3 times qs. So SR is equal to 3 times qs. And that is what we were asked to prove.